Hello, welcome back to math class. Today's lesson is going to be about this question here at the top of the page that you see. What conditions determine the number of triangles that can be made? We are going to look at various situations and be able to summarize how many different triangles can be made with certain conditions. So in your ISN right now, I want you to copy this chart. We will put the given conditions in the first column, and then we will either check or make an X whether it makes a unique triangle, more than one triangle, or absolutely no triangles. So go ahead and pause this video right now so that you can get the chart copied into your ISN. Okay, welcome back. Let's go ahead and fill in one of the given conditions, and we're going to use that problem that we learned earlier in the love triangle mid-school math lesson, where we had a 70-degree angle. We had a side length of 12 centimeters in between the other 70-degree angle. And if you remember when we drew this, we were able to create a unique triangle. There was only one triangle that could be created with a 12 centimeter base between two 70-degree angles. So what we're going to do today is we're going to look at some interactive websites here with GeoGebra. And the first one we're going to look at is another one very similar to the one that we just did in mid-school math. We're going to take this segment AB, and we are going to construct a triangle that has two angles at 97 and at 55 degrees with this 7 centimeter segment AB between them. So I'm going to take this and I'm going to just move it down here so we have a little bit of room to work. And I'm going to put this 55-degree angle here on B. And I may have to make some adjustments. I'm going to take this so that my angle is along that bottom 7 centimeter segment. I think that's pretty good. And then I'm going to take this 97-degree angle and I'm going to put it on the other side of this 7-degree segment. And we'll put it over here so that it aligns. And voila, here we have our triangle. We've got a 97-degree angle, a 7 centimeter base, and a 55-degree angle on this side. And you can see that it does make a perfect triangle that is unique. I cannot make a different looking triangle if I'm going to have a 97 and a 55-degree angle on either side of a 7 centimeter segment. So let's go back to your chart in your ISN. I had a 97-degree angle, a 7 centimeter segment, and my other angle was 55 degrees. And when I drew this, I was able to come up with a unique triangle. Let's go ahead and look at another exploration. I'm going to look at this one where we have 3 sides. We're going to have a side with a length of 2, with a length of 8, and with a length of 5. And the job here is to create a triangle. So what I'm going to do is I'm going to put this one down here, and I'm just going to go ahead and attach E over here to that side. And then I'm going to go ahead and put A over here on point D. And let's see. I seem to be getting farther apart. So what I'm starting to think is that I am not going to be able to create a triangle with the side lengths of 2, 8, and 5. So I'm going to go back over here to our chart, and if I have 2 centimeters, 8 centimeters, and 5 centimeters, this time I was not able to even make a triangle with that. So let's go ahead and look at another exploration. I have 3 more side lengths here, and I'm going to try to create a triangle with 8, 5, and 5. So I'm going to do the same thing that I did before. I'm going to go ahead and match up my vertexes here. See if I can end up making a triangle with 8, 5, and 5. Let's see. Oh, this one actually works. So what is the difference between this one working and the other one not? So I had 5 centimeters, 8 centimeters, and 5 centimeters. And this one gave me a unique triangle. I'm going to give you some others. I don't have any interactive websites to show you, but I'm going to give you some other information so that you can possibly figure out what is going on here, and we can find a shortcut so we don't have to draw these out all the time. What happens if I would have a 1 centimeter, 2 centimeter, and 3 centimeter side lengths? Would I be able to make a triangle? And in this case, I would not. A 1, 2, and a 3 centimeter sided would not create a triangle. What happens if I have a 2 centimeter, 6 centimeter, and a 7 centimeter? In this case, I would get a unique triangle. They would be able to connect to be able to create the 3 sides. Okay. We'll look into this in a little bit later when we get into our summary to see what in the world is going on here. I have one more thing I want to show you, and that is with 3 angles. If I have 3 angles, as shown here, I have a 33-degree angle, an 86-degree angle, and a 61-degree angle. If I shorten the side lengths, but the angles stay the same, do I still have the same shape of a triangle? I can even make it very small. So if I go back over here to my chart, and I have a 33-degree angle, a 61-degree angle, and an 86-degree angle, I actually was able to make more than one triangle. Let's go back to that. The angles never changed. The side lengths did. They either got bigger or smaller, but the angles never changed and the shape of the triangle never changed. Let's go ahead and let's just look at a 60-degree equilateral triangle. So right now all the angles are 60 degrees. If I change the side lengths, you will see that I'm still having an equilateral triangle. It's just different sizes. So let's go over here, 60 degree, 60 degree, and 60 degree angle. Again, I'm going to be able to get more than one triangle. So let's go down here where the summary is. I'm going to let you pause so that you can write these statements. And as you're writing the statements, if you can fill in the blanks, go ahead. I would probably fill them in with pencil, so that way when we go over them together, then you can check to see if you were thinking on the right track. Okay, go ahead and pause the video to write down these sentences. Okay, so with that, let's go over here and look at the first one. When given two angles and the included side, these are the first two examples that we had. So anytime I had a given side with two angles on either side of it, what kind of triangle can be created? A unique triangle can be created because there is only one way those are going to be able to be put together to get that triangle. Let's look at this one here. When three sides of a triangle are given, a triangle will only exist if. Did anybody find the shortcut for this? There were two cases where it did work. I'm sorry, this one here, the 585 and the 267, those worked, but the 285 and the 123 did not. So when three sides of a triangle are given, a triangle will only exist if two sides are greater than the third side. Let's look to see what that means. So let's look at this one here where we know it was created. Two sides are greater than the third. So 5 plus 8 would be 13. Is that greater than 5? Yes. Let's look at these two. 8 plus 5 is 13. Is that greater than 5? Yes. Let's look at the final combination. 5 plus 5. 5 plus 5 is 10, which is greater than 8. Maybe we should put this instead of if the sum of two sides. I like that better. So the sum of two sides are greater than the third side, then we will have a triangle. Let's look at the one that does not work just to test it out. So 2 plus 8 is 10. 10 is greater than 5. So that stipulation worked. Let's look at another combination. 8 plus 5 is 13. 13 is greater than 2. So that works. But if we look at the last combination, 2 plus 5, 2 plus 5 is 7, which is not greater than 8. And so that's why it did not make the triangle. The same thing is true for the 1, 2, 3 centimeter triangle. 1 plus 2 is not greater than 3. So that is why this did not make a triangle. One more. When three angles are given, what would you fill in this blank? If you said more than one triangle can be created, you are correct. And these triangles will be similar to each other as their sides are proportional. So I'm hoping this video has helped you understand when we're going to be able to get a unique triangle, just one, more than one triangle, or absolutely no triangles. So thank you for listening to the whole lesson. Go ahead and finish the rest of the assignment listed in Google Classroom.